Okay, welcome to the second part of a calculus review for advanced statistics. So let's solve the remaining questions. So we have a question on integration here. Let's solve it. Okay, so I'm gonna rewrite this. First, we can try to combine this expression because we have two e's there. So let's try combining the e's to further simplify the expression so that we can integrate it. So we have 1 over beta here, or okay, I can just write it with it inside the integral or outside the integral, doesn't matter. We have e to the power of. Now what I want to do here, I want to combine the e's together and factorize 1 over beta outside the brackets. So we have something like this. So it's going to be the inside the brackets. We will have plus 1 here. And then we would have minus beta t. So that if you multiply beta into minus 1 over beta into the brackets, we will have minus 1 over beta x plus t x. Okay, now moving on here, let us integrate it. Okay, so integrating it, we'll have 1 over beta as it is times e to the power of minus 1 over beta 1 minus beta t x. Now, because you know the integration of t does itself, but remember reverse chain rule, so we have to multiply it by the reciprocal. Oh, sorry, the reciprocal of this, which is just, well, we'll have minus beta here times 1 over 1 minus beta t. So betas will cancel. We'll be left with, oh, remember this is from 0 to infinity. Okay, so it's an improper integral, but it's definite. Okay, so we'll have minus 1 over 1 minus beta t times this thing right here, minus 1 over beta 1 minus beta t x from 0 to infinity as our limits. Now, you can just take the limit when you substitute infinity, because technically we can't directly substitute infinity, but for simplification, I'm just gonna maybe skip that step. But we know the concept already because the power is negative here, which means if you plug in infinity into our x here, it's gonna be 0. So the first term is gonna be 0. And then 0, e to the power of 0 is just 1. So we have something like this, because there's a minus sign there. So minus is plus. So we have 1 over 1 minus beta 2 is our final answer, because e to the power of 0 is just 1. All right. Now moving on to the next question. The function below is continuous and differentiable. It has a global maximum at its critical point. Now we need to find this expression right here, or function. It could be f of x equals to that thing. We need to find that using first order condition. So we need to find the maximum p in this case. Okay, now let's first of all first things first, this expression right here. It looks complicated, but trust me, we can definitely do something to make it less complicated. Okay, so let's attempt making this function less complicated. So this is going to be equal to, what I'm going to do is I'm just going to expand this. So I'm going to bring the n into the brackets. So what does this mean actually? For those who aren't familiar with this symbol, that means product. So it means multiplying instead of adding, instead of addition. So we're probably familiar with sigma. That means sum, the sum of all of that. But this means product, means multiplying. Okay, now with that in mind, let's just bring the natural log into the brackets, and we'll have, instead of, remember the property of natural logs, or logs in general, when you have products of something and you take the logarithm of it, it's just the summation of the logs of that thing. So when you, I hope that makes sense. Let's just try to write it down to make it clearer. Okay, so when you bring the ln into the brackets, we're going to be left with sigma. Something like this. Okay? Or you can write our brackets there, add extra brackets to make things less confusing. So that equals to, now let's further expand this. So what I wanna do here, I wanna multiply the sigma. Remember, the sigma operator is linear. So the way we operate it, it's just like a linear operator, okay? So we don't have to be too confused about it. Okay, so we have sigma ln of that plus the sigma, same I from I to n of the ln of this thing right here, 1 minus p minus xi. Okay, now let's further simplify it. I'm just gonna write it here to save space. I'm gonna take the powers down, okay? So what's gonna be left here? If I take the power down here, we'll get xi, so ln p, xi ln p, right? But I'm gonna take ln p out of the sigma, because it has nothing to do with I in this case, so xi left. Now the same thing goes with the second term, okay? Take out ln 1 as p, sigma equals 1 to n of 1 minus xi. Okay, something like that. Now, let's see if you can further simplify this. Right, we can. We can further simplify the second term. Or maybe I can just, okay, I'm going to copy and paste it here, because we can further simplify the second term here. Now, sigma of 1 is just n, right? This one will just be n. And then the reason is that if we keep on going from 1 to n, it's just going to add up a bunch of 1s. And then there are n 1s. Oh, my bad. It looks terrible. Yeah, there are n 1s, so they're going to add up to n. So it's not like you're adding up 1, 2, 3, 4, 5 up to n. Because there's no I here, so we're just adding that 1, that constant there, just multiplied by 1. So if there's a constant, you take the sigma from 1 to n. If that constant, you're just multiplying that constant by n. N times that concept. For this though, it's different. It's this, if you have something like this, it's like adding x1, because we're starting from 1 here to n, so we're adding x1, x2 all the way up to xn, like that. So that's a concept behind that. So we can still further simplify the second term into, well, there's n here, n, and then sigma. Okay. This is going to be n. So we'll have n. And before it's minus sigma. So 1 to n. Something like this. So, well, if you want to further, you know, expand that to make things easier when we apply the first order condition, which is differentiating it with respect to p, right here, first order condition. We need to differentiate our our function here with respect to p, my bad, and equate it to 0. So it is going to be easier if we expand this, I believe. So n ln 1 minus p, and then minus ln 1 minus p times sigma I equals 1 to n of xi. Right, something like that. Now, let's differentiate that. Okay, so let's say this is, okay, this whole thing is f of x. Okay, this whole thing is f of x. Now, let's differentiate it. df over dp. We have first order condition here. Or we can use a partial as well. But we can also use, it really depends on the number of variables that we have. That's going to be equal to, again, we're differentiating with respect to p. So let's differentiate the first term first. That is just 1 over p times this. So sigma I equals 1 to n xi over p. And then this, well, it's just the derivative of this, which is 1 over 1 minus p, times the derivative of 1 minus p, which is minus 1. So chain rule, so minus n over 1 minus p. And then same thing goes here. That's going to be plus, right, because of chain rule. Over 1 minus p. And that's going to be equal to 0. First order condition. Okay. Now we're going to have to solve for p. Okay. Let's see. What's an easy way to solve for p here? Okay. So what I'm going to do now is bring probably, okay, let's see. I'm going to bring this term. Actually, let's try just bringing this term to the other side of the equation. Or these two terms to the other side of the equation. It really doesn't matter. Okay. Now this is going to be equal to n minus sigma over 1 minus p. And then let us cross multiply. I'm just going to, for simplicity, I'm not going to write I equals to 1 to n anymore, so that we can save time. Okay, and then, yeah, we're just cross multiplying, right? Okay, now, expand both sides. Oh, my bad, equals to p. Okay, you've got both minus p sigma xi on both sides. They cancel, become 0. Now Pn is equal to sigma xi. So P is equal to sigma xi over n, which is the same thing as, you know, P is equal to sigma equals 1 to n, sigma over n. And this thing is x bar, right? So that's our P. And that's it for the calculus review for advanced statistics. I hope this video has been helpful. And if you have any questions or any other video requests, feel free to leave a comment below. Thank you.